can use it in a number of different ways. One way we could use it would be to go over some slides that I've selected from many, although not all, of the presentations that I've made, with the understanding the slides capture a lot of the key things and kind of expect you to understand for the exam. So that's one way we could use this time. Another way we could use this time would be for me to field questions from everyone here. Answer questions about the meaning of the ampersand character on the shell, or about how include works in C files, or about how square brackets work with regular expressions, or something like that. I'm glad to answer questions of that sort. Another thing we could do is you could ask me to expand on a broad topic, which seemed confusing, and I could actually call up the slides and go through it. Or we could talk about particular examples for problem sets, etc. I should note before beginning that I've gotten some emails from some people about setting up individual appointments, and this week is horribly busy, but I'm trying to find slots for people. I can't guarantee they'll be prior to the exam as much as I'd like for them to be. I've met with some people already, but just trying to meet with everyone, it's hard to do that. I did have my office hours yesterday, and continue having them after every class, but I'm hoping that I can have these one-on-one meetings as well, but it just takes a bit of time to schedule things. So apologies about that. Okay, so how many people here would like me to sort of go through some slides which, for me, capture some of the major components of what we've covered thus far in the class? Okay. How many people would prefer to ask very detailed questions? Not a single person. Okay, well, I can see who's doing work here. Fine, yeah, I've gleaned some slides, and they are worth noting. I'm not going to try to go through them with as much emphasis as I did the first time, because you've seen them before, and my goal here is not to communicate the material for the first time and explain it all. My goal is to emphasize what I consider important enough to be worthy of being on the exam. And if you have questions about anything that I am covering, just stop me and say, what's going on there? Why is that? Why do you say that? Whatever. Just stop me, okay? But I'm not going to try to cover all the points in each slide. I'm just going to sort of a bit of a narrative flow. Now, I have to confess that in preparing for this, I didn't get through all of the lecture material. I paused down somewhere in October with some of the slides, and I'm happy to kind of go through those missing lectures if desired, but a lot of them are kind of abstracted the piece of what you do see here. For example, I've studied regular expressions here, even though I don't go into every single operator like I did in my sickbed video for you one time. Okay. Okay. So fine. I think the demos has spoken, so we're going to go through some topics. So we started out this course with a substantive discussion of Linux operating within Linux commands, Linux concepts, things like a process, for example, things like streaming. And we further talked about ways that we can compose Linux programs using things like pipelines into multiple pieces, or using redirection, for example, or builds up a higher level thing from its pieces. So I have some slides related to Linux, not surprisingly. And in fact, if I were you, I'd study what we covered in Linux. That took a good number of lectures, and chances are, good as not, that it will cover a good number of questions. So when we talk about things in Linux, we talk about commands, and I noted that commands are the default forms. You have command name, and then you have some options for that command name, and then you have some arguments for the command name. The options, what's an option? Give me an example of an option. Sorry? Yeah, minus D, or minus L, or minus SC, or whatever. Okay, so that's good. An option can have multiple letters in it, some minus help, for example. Or in some cases, like GNU, Project GNU-oriented derived software, you have often minus help, something like that. So options sort of tell the command sort of what variant of its processing to do. So it says, hey, word count, only report the number of characters. Or it says, for unique, only report the number of unique lines. Or it says for graph, match all things not, show all lines not matched by this regular expression. Kind of tells the variant of its processing to use. And then arguments are sort of, are the things it needs to do its job. So what would graph need to do its job? Or what could it use to do its job? Apply. Or set applies, right? So I could do grep. I could grep for something that begins with capital A or capital B, and then has after it, B1, something like that. And I can do that in foo.txt, and bar.txt. So here, what are these things? They are the arguments. Now, if I did grep minus v, that would be an option, right? Okay. So terminology there. So that's good. What would the interpretation be if I did something like the following? If I took away the quotes here, what would happen? Sorry? Yeah. So, well, actually wouldn't be per se an error. What's actually going to happen is that so some of these things are interpreted by the shell. What do I mean by the shell? So suppose I said, star.txt. Who knows about the star? Who interprets it? Who makes sense of it? Who understands the meaning of it? Good. Were there hand up? So any character? Okay, but who actually makes sense? Who knows this meaning? A shell. Does grep get to see this star? No, it never sees the star. Might think it's a little cloudy for grep. So it never sees the star. By the time it gets this thing, this has been expanded. What I mean is this gets turned into whatever things are here. So maybe it gets turned into, for example, foo.text.txt and bar.txt. So what was originally star.txt got interpreted by the shell and got expanded into this, right? And the problem is the shell doesn't know what thing is supposed to be. It doesn't know what grep expects in these places. So it may think this is a file name. Does this mean something to the shell special? Yeah, it turns out the shell also has sort of things you can put in the stars and these sort of things. So in general, when you have regular expressions, because we like to put these single quotes around so that the shell doesn't get its mucky hands on this and try to interpret it. Because it might see a star in here, dot star or something, and it tries to actually expand this as if it's a file. You can get weird things happening if you're trying to interpret that as a file name. So to prevent that, we actually put a single quote around it. Right? Okay. So here we have grep. Grep is a program, and like any program you write, it like can see something main, and you can treat it as taking a certain number of arguments, a count of arguments, and then there's actually a sort of a set of things passed to it as its these are excuse me, an argv array, an array of strings that are passed to it as its arguments. And the point is, the shell has already processed this stuff. The shell has processed that stuff. It's processed things like bang bang, which are history characters. It's processed things that are like $ home or something like that. It's taking care of all of that, so grep doesn't have to. Grep doesn't have to do it. If you write a program, it automatically gets the free interpretation of this stuff so that you can give your program, maybe you have a program called myprog, and if you pass it, star.txt, what your program will see is, as its arguments, the actual names of the files. So you won't have to worry about it. So you should realize kind of the shell helps out. It takes care of these interpretations, okay? It takes care of them so the programs don't have to, okay? These commands, which represent programs typically in Linux. Now, I thought I had another one of these, so I'm gonna nuggetize this.